This video is for parallel lines and perpendicular lines notes. So yesterday we looked at just horizontal and vertical lines. Today we're going to look at some different examples of lines that are parallel and perpendicular. So parallel lines will always have the same slope. Perpendicular lines are going to have the opposite reciprocal slope. So first off, parallel lines. Parallel lines are two lines that never intersect. They're never going to cross. And so algebraically, how do we know that two lines are parallel? The slope is the same and the exact same. So 2 and negative 2 are different. Those are not the same slope. So they would have to both be a positive 2. Perpendicular lines are lines that intersect to form right angles. So they're always going to cross at a T. They're always going to form that right angle. So algebraically, how do we know that two lines are perpendicular? They have opposite reciprocal slopes. And so what does that mean? What is opposite reciprocal? So a reciprocal, to start off with, if we have a fraction 3 over 4, the reciprocal of 3 over 4 is 4 over 3. Now to make it opposite, we change the sign. So if 3/4 is positive, the reciprocal is going to be negative. So 2. If we write 2 as a fraction, that's 2 over 1. So the reciprocal is 1 over 2. 2 over 1 is positive, so that means 1 over 2 has to be negative. So you change the sign and you flip the fraction. So negative 7/8. If we flip the fraction, we get 8/7. 7/8 is negative, so that means 8/7 is positive. 1 is kind of a special case. 1 over 1 is the fraction form. So if we flip it, we just get a 1. But since this one is positive, this one has to be negative. And then 0 is another special case. So remember, lines that have a slope of 0 are horizontal lines. So the reciprocal here is 1 over 0, and you can't do that. You can't, so if we have 0 over 1, the reciprocal of that would be 1 over 0, and this is not possible. You can't put 0 in the denominator of a fraction. So this is one of those that you just have to know, that a perpendicular line to a horizontal line is a vertical line, and the slope is going to be undefined. And that is because 1 over 0 is undefined. You can't do it in math. All right, so on this bottom part, we're just going to determine if these lines are parallel, perpendicular, or neither. So all we need to do here is find the slope of these lines. So what I'm going to do is I'm going to do linear regression. So AB, and I'm going to do M of AB, the slope of AB. So I'm going to go to stat, and so my x's, negative 2 and 2, and then my y's, 3 and 6, and we do stat, right arrow key 4, and all I'm looking at here is just the slope. So the slope is 0.75, but I want that to be a fraction. So the slope of AB is 3/4, and then the slope of CD. So if you need to, with these points, stack them up to do linear regression. Draw a line down the commas, L1, L2, if that helps you. Oh, sorry, it froze. All right, so my x's are negative 1 and 3. My y's are 0 and 3. And my slope here is 0.75 again. It's 3/4. So when the slopes are the same, these are parallel lines. Okay, so on the next one here, so the slope of AB, so if I stack them up, 0, 2, 5, 4, all right, 0 and 5, 2 and 4, stat, right arrow key 4. So this time I got 0.4. So 0.4 alpha y4 is 2/5. And so the slope of CD, I've got 1 comma 8 and 3 comma 3. 1 and 3, 8 and 3, stat, right arrow key 4. Oh, didn't mean to do that. So I got negative 2 fifths. So negative 2.5, turn that into a fraction. I get negative 5 over 2. So these are negative reciprocals. So these are perpendicular lines. Okay, on the next one, the slope of AB. So I've got negative 1 comma 8 and 2 comma 6. Negative 1 and 2. 8's already there, so 6. Stat, right arrow key 4. Okay, so negative, so we ignore this 7. Remember, your calculator rounds it off. So it's negative 0.6 repeating. So remember, you type in the repeating number until that arrow pops up right here. And then you can alpha y for it. So the slope of AB is negative 2/3. And I need to find the slope of CD. So stat, right arrow key 4. I get 0.25. 0.25 as a fraction is 1/4. So in this case, they're neither. So the slopes aren't the same, and they're not negative reciprocals either. Okay. All right, so on this next page, we're going to determine the same thing, if they're parallel, perpendicular, or neither. So all we're looking at is the slope, and these are in slope-intercept form. So the number in front of the x. They're both 7s. The slopes are both 7s. So these would be parallel lines. Okay, on this one, I've got a slope of 4/5, and then I've got a slope of negative 5/4. So they're reciprocals, and then one's positive and one's negative. So these are perpendicular lines. Okay, got one more in slope-intercept form here. So I've got negative 1/3 and positive 1/3. So they're not the same. One's negative, one's positive, and it's not a reciprocal. So the number's the same, 1/3 and 1/3, just one's negative and one's positive. So these are neither. They're neither parallel or perpendicular. All right, on 13, now they're in standard form. So we need to change them to slope-intercept form. So the name of the game here is to solve for y. So x plus 6y equals 30. All right, and then we're going to have to do the other one too, so I'm going to go ahead and write that one down. 3y equals 18x minus 6. All right, so I need y by itself. So I'm going to subtract x from both sides. So I've got 6y. I'm going to write the x first, and add the 30 because it's positive, and then I'm going to divide every term by 6. So these cancel. Negative x over 6 is the same as negative 1/6. Tack on the x. 30 divided by 6 is a positive 5. On this one, all I have to do is I just need to get rid of this coefficient of 3. So I'm going to divide each term by 3. So 18 divided by 3 is a positive 6. Tack on the x. 6 divided by 3, negative 2 because of that sign. So if I look at my slopes, negative 1/6 and positive 6. Negative 1/6 and positive 6, which is 6 over 1. They're reciprocals, and they're opposite reciprocals. One's negative, one's positive. So these lines are perpendicular. All right, 19, same thing. All we have to do on this one is just switch 5x minus y equals 4. We need that one in slope-intercept form. So subtract the 5x from both sides. Now I've got a negative y equals negative 5x plus 4. Now, I can't have a negative y. So to get rid of this negative, I'm going to divide everything by negative 1. So that cancels out that negative, and I'm left with just a y. Negative 5 divided by negative 1 is a positive 5. 4 divided by negative 1 is a negative 4. So here we've got 5x, I'll write it here, y equals 5x minus 4, so I have a slope of 5. And then here I've got a slope of negative 1/5, 5 and negative 1/5, so again 5 over 1. Negative reciprocals, so these are perpendicular lines. And then the last one here, so 3x minus y equals 2, and 12x minus 4y equals 4. All right, so we want y by itself. So we're going to subtract 3x from both sides. Negative y equals negative 3x plus 2. I need to get rid of this negative, so I'm going to divide everything by negative 1. So that cancels that negative. Negative 3 divided by negative 1 is a positive 3. 2 divided by negative 1 is a negative 2. All right, on this one, I'm going to subtract 12x from both sides. So I'm left with a negative 4y equals a negative 12x plus 4. Divide by negative 4, divide by negative 4, divide by negative 4. So these cancel. Negative 12 divided by negative 4 is a 3. And then 4 divided by negative 4 is a negative 1. The slopes here are the same, so I'll rewrite these. Y equals 3x minus 2 and y equals 3x minus 1. Slopes are the same, so these are parallel lines.